Hello, welcome to another problem session. So here we have a circuit which is shaped with like this, with three straight segments and a semicircular segment over here. And this is a steady current. Current is steady. A steady current is flowing through it, and supposed to find the magnetic field at that point. And there's a condition that this length of this wire is much greater than this, and of course this distance is 2r, because the radius and this 2r. So first thing notice that if this distance is very far and this very small wire, so magnetic field from this part over there will probably, we can ignore that. So let's kind of do A, B, C, D. So what will be at B at P? B at P will be from superposition principle. So this will be made up of from this part, which we just talked about, probably ignorable, plus B to C, and let's do D to A. So these are like straight segments, and then semicircular B from C to D. Okay, this part is done in a previous video. So if you want to go check the other video, which will be a circular. So in a previous video, we did for a, if I going in the full circle, then I need to do this integral, and from there the B at P for the full circle is equal to mu naught I over 4 radius. Yeah. So this is done in a previous video by and this coming out as, say, this was X and Y and Z was like that. So this will be K hat direction. So this is done in a previous video. So this is going to use half of that, because I'm going to do half the integral. So B of CD semicircle will be, so again I'm going to do say this is X and Y, maybe Z is coming out, so I'm going to keep that direction fixed. So that's the direction from there, and all of this will be, if you use the right hand rule, all of this will give you coming out direction for the magnetic field over there. So K hat will be mu naught I over 4, I think it's a 2r, not 4r, it's a 2r. 2r, yes. So how about these guys from B to C and D to A? These guys, you can kind of set up this integral and take a limit and see what comes up. Okay, so maybe you can do the integral and come check how I did that. Okay, so what we have, we want to have dl. So dl is just dy prime j hat, and this straight vector r from dl to the point P. So this vector is going to be x I hat for this point minus this vector minus that vector. then y prime j hat. So that's the vector r, and we can do dl. We want dl r over r cube. U hat is simply r over r. So when you put in there dl cross u hat over r square, then with this you get that. And so you can see j hat with I hat is going to be minus k hat, and it's going to be x dy prime, and unit vector of r, actual size of this vector will be x square plus y prime square, and then cube will be, that will make it 3/2. So this is the one I want to integrate from, this is minus L over 2 to 0. So this integration is coming from 0 to minus L over 2. So I got mu naught I over 4 pi, and so I am going to integrate x dy prime over x square plus y prime square 3/2 0, actually to minus L over 2, and there's a minus sign, right? So and this k hat. Well, this x is actually equal to r for us. When you do this out, so x doesn't depend on anything, so the x is like that. So when you do this out, what I'm going to get is this integral. I can pull the x out. Let's do this integral out. So minus k hat mu naught I x, and I pull x out. I have a 4 pi x cube 0 to minus L over 2 d, and let's do one more change. Okay, just leave it like that right now. I have a x square pulled out, 1 plus y prime over x square 3/2. It's like that, right? So I pull the x out common, and you can see that one of this, it becomes square, and let's take this and use that, and then use this 2 over x. So u, I'll just keep it 1 over x right now here. So u equals to y prime over x, and so this is going to be turned into minus k hat mu naught I over 4 pi x 0 to minus L over 2 du over 1 plus u square 3/2. And this integration is easy to do. Minus k hat mu naught I over 4 pi x, and it's going to be u over square root of 1 plus u square, and this is 2 over x minus L over 2 over x. Okay, let's see what we have here. So this thing is just turns out to be, minus will kill that minus, so we have a k hat mu naught I over 4 pi x, and then you have a L over 2x times 1 over square root of 1 plus L square over 4x square. Now we have L much greater than R, right? So these are all R's. This is R, this is R. So this quantity will come out, right? And this will dominate, and this thing and this thing will actually cancel out. So this is what I got. So this will be all that will be left. All right. Okay, so we got the dA. Then to get B to C, we can do the same kind of integration, and eventually you're going to get the same answer. Or you can have kind of a symmetry here. So if this current is producing this kind of magnetic field, this current will produce same kind of magnetic field, and use the right hand rule, and you can see the same direction. So B from BC is going to be exactly the same, mu naught I over 4 pi R. So now we're left with B at AB. Okay, B at AB, you can kind of see that we will end up something like this, and with the R, which is the distance of this X will be this distance, and if X goes to infinity or very far, so in that way is this going to be 0. So this will be 0. So we need to add this up, and then B at P will be adding these up, and you can see that's the answer, mu naught I over 2R from this guys, and from this they're the same thing. So K hat mu naught I over 4 pi R times 2, and which is the answer that was given earlier in the problem. So that's the answer. Okay, this is a little bit hard problem. Sometimes this problem will be asked by not giving this altogether, just this structure. Sometimes a variant of this problem will be like, okay, if I give you a square, all of this distance is L, and then I can ask you what's the magnetic field be here if these have current I going around them. So that's another variation, same kind of math. You just figure out for one, and then will be very similar to how we worked out this guy, right? There would be I would have done over there, you could have done instead of square, you could have asked this very long, and so instead of a square you have only 3 sides, and maybe some arbitrary point P over here. Okay, so these are the variation you can practice. Now I just want to ask you, if you haven't subscribed, please subscribe so that it can grow the channel, and tell your friends and other students who are studying, maybe they can get help from this channel. I'm solving a whole bunch of problems. Now I'm to the magnetism, then I'm going to go into electromagnetism. This is steady current. What happens when there's a non-steady current? That's the question we want to answer next. But before we get there, I'm going to do Ampere's law. There are other concepts like optics that's coming up in the future. So you may want to subscribe. If you like this kind of explanation, definitely hit the like button. I appreciate that. You can check out my website. There's much more detailed explanations on concepts as well as many more problems. Okay, that's it for now. Talk to you later. Bye.